So let's continue with our lecture 2. I think this should be part B or part C. I'm not sure because I'm going to edit the video. So I'll just quickly, maybe I will summarize what we saw so far. Yeah? So we tried to draw the process flow diagram for the VCM production, and in fact I showed you some process flow diagram in the simplest possible way. So I will try to repeat. So we will begin with ethylene, and then we are going to split this fluid stream into exactly half, and then we will have chlorine, and then we need hydrochloric acid. So we mix them in the CSTR, and then the oxychlorination we will perform it in a catalytic reactor. Here we will model it like a plug flow reactor. So both the direct chlorination which we are going to perform in CSTR, and also the oxychlorination reaction which we are going to perform in a PFR, we are going to use catalyst, will be CuCl2 catalyst. And I already mentioned the process conditions. So so the direct chlorination, I think we will perform at 60 degrees centigrade, 1.5 atmosphere, and then whereas this heterogeneous catalytic reaction that we are going to perform at slightly elevated temperatures. So let me check my notes. Yeah, this one we are going to perform at somewhere between 220 to 235 degrees centigrade. Yes, so this will be, we'll perform this experiment at 225 degrees centigrade at 4 atmospheres. So we will take the product out, we will mix them. This mixture should contain hydrochloric acid and then the main product, which is ethylene dichloride, and this is an ideal world. Yeah, sometimes we might end up with some unreacted product like ethylene, and sometimes we may even have trichloroethane, sorry. And then I also mentioned how we are going to separate. I showed you I already mentioned what they do it in the, what they will do in the industries in order to purify ethylene dichloride. So we are going to do something like we are going to install a flash separator in order to separate lights from the heavier compounds. And this one we are going to maintain the temperature in the flash separator like 15 degrees centigrade, so which means your water will be in the bottom, plus your main product, which is ethylene dichloride, will be in the bottoms, and then the lights, which will be HCl or maybe some organic compounds. And some air products. And then we are going to, from the flash separator, we might get somewhere like we will achieve a purity of roughly 60%, and then we will take this stream and then we will add a liquid extractor, say like 5-stage liquid extractor, and then we will use water as the solvent, or you can call it as a extractor. So water will carry your ethylene dichloride and then it will come in the bottom. Oh sorry, using water as a solvent, so water will strip all the organic compounds, so you will get water in the bottom, and then you will get a purified product, ethylene dichloride. So at the end of your liquid extraction, you will have two phase. This will be your water, and the second phase, the lighter phase, will be your ethylene dichloride. So you will have some clear phase separation due to the density difference between these two fluids. So this way we will achieve somewhere around 90% purity. So this is a liquid extractor. So this is perfectly fine. And then we take the product from the liquid extractor. And then we will send this fluid. We check the temperature and everything. Let me check my notes. This liquid extractor, we will maintain a temperature of again 15 degrees centigrade, and then it will be 4 atmospheres. So we should take care of this the process condition. It's really important. And again in the flash separator it's the same, 15 degrees centigrade, 4 atmospheres. So we get all this information from the literature or probably from the patents. And then we add a liquid extractor. From the liquid extractor, this stream should contains roughly 90% ethylene dichloride, and our main goal is to get near to more than 99%. We need to achieve 99.5% ethylene dichloride in the product stream. And I already said why is that, because if we have some impurities, then in the pyrolysis chamber it will end up with some formation of scales in the pyrolysis chamber, plus we also need to avoid coking. So that's why we need to get a very pure ethylene dichloride intermediate. This is an intermediate product, and we need to achieve a very high level of purity. Yeah? So that's the main reason we are purifying. In fact, we can go for direct pyrolysis. The moment we take the product from the CSTR and plug flow reactor, we can take this ethylene dichloride and go for the third step, pyrolysis. But this is not advisable, and as I said, it will create coking, and also it will also create a lot of fouling inside the pyrolysis chamber. And that's the main purpose we are purifying this particular stream, and we need to get 99.5% of ethylene dichloride. So it's doable. So we take the stream from the liquid extractor, then we pass this stream to a 17 stage. The number of stages we can even decide later. Yeah, so we can even change it to, can begin from 10 stage, and then we can increase the number of stages and see how pure the product is, the final product is. So I already did perform the calculations in my computer. So for the moment, let's stick to 17 stage reboiled absorber. Sorry, this is not a distillation column. This is 17 stage reboiled absorber. So what we are going to do is we have a reboiler here. Then you get your light product in the top. In the top, we will collect the hydrochlor. Okay, it will be your impurities. It will be hydrochloric acid. In this case, we are assuming that the byproduct will be only hydrochloric acid and there will be no impurities. That's the assumption we are making at the moment. And then in the bottom, we will get pure ethylene dichloride. If you check the purity, it will be near to 99.5% or maybe more than that. So So this is a 17 stage reboiler, and then we are going to maintain the same temperature of 15 degrees centigrade and 4 atmospheres. Throughout the adsorber. So once we have this 99.5% pure ethylene dichloride, we can go on to the next step, which is pyrolysis. I hope you all remember the reaction stoichiometry. So let me write it here. We are going a bit slow, but that's okay, You will see why we are. You will understand why we are going very slow. So we take this ethylene dichloride, then we pyrolyze this product in order to get vinyl chloride monomer Cl plus HCl. As I said, this should be an endothermic reaction because we are going to supply some heat. That's what pyrolysis is about. We are going to add some heat. And what's the temperature for pyrolysis? So typically we are going to, typically in the industries they will pyrolyze at 480 degrees centigrade to 530 degree centigrade and at a pressure which typically range from 6 to 35 atmospheres. And normally they will use a long tubular coiled placed in a furnace in order to pyrolyze these products. So in this case, in Aspen, we are going to use it like a plug flow reactor. So this will be our pyrolysis chamber, and then we are going to pass the stream at, I don't know what temperature we can fix. So let's fix the high, say like roughly 550 degrees centigrade. And we can even go just to 530 degrees centigrade, the highest temperature, and at 26 atmospheres. So let's put 550 because that's what I found in the literature. So, but obviously, when you are going to when we are going to try to draw the flow sheet, we can change the process conditions and then we can see how it affects the product purity or the percentage conversion. So let's put 550 degrees centigrade at under 26 atmospheres, and then so if you remember the stream that comes out of a reboiler, it will be at 15 degrees centigrade and 4 atmospheres. So which means we need to raise the temperature, and then we also need to increase the pressure to 26 atmospheres and temperature to 550 degrees centigrade. So keep those these tiny details in your mind, and then obviously we need a rate kinetics, so how fast the reaction proceeds, and this is available from literature. So rate is proportional to a kinetic constant and is multiplied by the concentration of the ethylene dichloride. Again, the unit is in kilomoles per meter cube per second, and this values, this expression was reported by some authors in the literature. And if you want to check the paper, you can check it yourself. It's published in Computers and Chemical Engineering. Computers and Chemical Engineering, volume 23. I think year is 1999, and page number 479 to 495. So this is how you need to get the information from the literature, and then you need to select some particular rate expression that dictates the the process. So in this case, the rate of the reaction follows a first order kinetics, and then the rate expression is given by K multiplied by the concentration of ethylene dichloride, and this K value, where K is equal to, K is the kinetic constant, so K is equal to some big number 10 to the power of 13.6 exponential minus 242,672 by RT. This is a first order reaction, so the unit will be 1 by seconds for the rate constant. And another author, Demian and Vildia, I don't know how to pronounce this name. It's from the book Chemical Process Design. Computer aided. In fact, I am following this book, Computer Aided Case Studies. I have this book right now on my table. So they modified this expression in order to bring the result closer to the industrial data. So K is equal to 1.14 into 10 to the power of 14, some really big number, exponential minus 672 divided by RT 1 by seconds. So this is in, the activation energy is in joules per mole. Yeah, so pay attention to the units. So units are really important. If you did some mistake with units, then you will get completely weird results when you are going to perform the process simulations. So we already have some good level of information. Yeah, so this is the third reaction that we are going to perform. As I said, the manufacturing of a vinyl chloride monomer involves exactly 3 chemical reactions. We already learned about direct chlorination, and then we learned about oxychlorination, and now we also covered the pyrolysis. Yeah? And we also know what's the temperature, what's the pressure at which we are going to perform all these 3 chemical reactions. Yeah? So like for direct chlorination is at low temperature 60 degrees centigrade, near to atmospheric pressure 1.5 atmosphere, and then oxychlorination is at slightly higher temperature, I think 235 degree centigrade, and then at 4 atmospheres. And then your the pyrolysis we are going to perform really at very high temperature, around 550 degrees centigrade, and at high pressure 26 atmospheres. So, and we also have the rate expression for all these three reactions. So what we are going to, and then so from the pyrolysis chamber, so put ethylene dichloride. After pyrolysis we will get some product stream that should contain vinyl chloride monomer plus some of the impurities. In this case it will be hydrochloric acid, and then some of the unreacted species, which can be ethylene dichloride. Yeah, so this is your part of your unreacted reactant. So these are the impurities that we may encounter in the products, and we need to produce vinyl chloride monomer, something like a polymer grade. So it will be around 99.5% purity. We need to purify this particular stream. So what we are going to do, so obviously to purify this we may need more than either 1 unit operation or maybe more than 1 unit operation. Yeah, so in this case we are going to use distillation. This is something you need to pay attention as a chemical engineer. So we are going to use use distillation. Yeah, let me check my notes just to make sure we are going in the distillation. So you will have a reboiler in the bottom, you'll have a condenser in the top, and then since we talk about the distillation, so always keep in the mind, I think I wanted to say few things in this topic. I don't want to miss it. Before going into this distillation, one thing we need to remember, the stream that will come out of the pyrolysis chamber will be really at a higher temperature, yeah, because we are maintaining the pyrolysis chamber at a very high temperature of 550 degree centigrade. So and then so once the stream comes out of the pyrolysis chamber, we need to quench the temperature of the stream. If not, you will end up with coking, and sometime your main product will start to degrade with respect to time due to the high temperature. So normally we have to drop this temperature. We have to quench the system, and then we have to drop the temperature, but we don't have to reduce the temperature directly to 15 degrees centigrade, because we are going to purify this final stream, and depending on what unit operation that follows this, that we are going to use to purify this particular stream, we can reduce the temperature according to the process condition that we are going to like temperature and pressure that we are going to maintain in the next unit operation, which we are going to use to purify this particular stream. Yeah. So in this case, I'm going to use a distillation. We have a reason to select a distillation. We will learn that while we are going to use Aspen HYSYS, like why we decided to go for a distillation column in order to purify this particular stream, or in order to get a purified product, which is a vinyl chloride monomer. Yeah. So we will use distillation to separate VCM from hydrochloric acid and ethylene chloride. And since we are going to talk about distillation, one thing you should remember is like we have to operate the distillation column in the temperature. Typically, temperature should be below 186 degrees centigrade, and then typically the condenser temperature should be in the range of condenser temperature should be in the range of 25 to 49 degree centigrade. And why is that? So if you're going to operate the reboiler temperature, to be specific, reboiler temperature, so normally we call like we say the distillation is considered to be economic only if you operate, or only if you manage to maintain the reboiler temperature at less than 186 degrees centigrade, and then if you manage to maintain the condenser temperature within this range, 26 to 49 degrees centigrade. So what do I mean by that? So you have a distillation column, so you have the reboiler in the bottom, and then you have the condenser in the top. Yeah, so you're going to, and then what I mean by this is like we have to maintain the reboiler temperature less than 186 degrees centigrade, and then you have to maintain the condenser temperature in the top. T should be less than, not less, it should be within this range, 25 to 49 degrees centigrade. And why is that, and why these conditions ensure the ensures, how do you call, like an economical distillation. So if you operate your distillation column within this range, then we can claim like we are the process will be slightly economic. How to say that? Let me draw it, then I can explain a bit. So in order to create this 186 degrees centigrade or temperature typically less than 180 degrees centigrade, we can use simply a low to medium pressure steam. So that's the main reason. Yeah? So that's why it makes the process a bit more cheaper. Yeah. And then in order to maintain this 25 degree to 49 degrees centigrade, so we will cool the fluid using some cold fluid. So we can use instead of some expensive refrigerants, we can use a normal, for example, air or water from the river, like a cooling water from river. So that's why these two conditions make the process more economical. I hope you all understand. And then obviously you have some feed which goes inside. So we need to fix these conditions. So we will try to find the perfect conditions that allows you to separate your product, in this case vinyl chloride monomer, from hydrochloric acid plus other impurities, if any, plus ethylene dichloride in that. So we are going to collect vinyl chloride monomer in the bottom, and then we are going to we are going to collect vinyl chloride monomer in the top, and then ethylene dichloride plus other impurities, if any, in the bottom. So let's, and another thing which is important is like so you should know the temperature that will allows you to boil the vinyl chloride monomer, and then you should also know the temperature at which you can condense the vinyl chloride monomer back to liquid state. So how to fix this temperature precisely? So what temperature I need in the condenser? So what temperature I need to fix, or what should be my condenser temperature, and what should be my reboiler temperature? What should be my reboiler temperature? Obviously we can get some idea from standard textbooks, or we can go to NIST fluid, but we will use Aspen HYSYS to get these values. So we will see at what temperature we need to maintain in the condenser, and what temperature we need to maintain in the reboiler, that ensures you will get vinyl chloride monomer in the top of your column. Yeah. And apart from that, we also need to know which stage your feed enters, and you also should know how many stages are there in the distillation column. So number of plates, number of theoretical stages, number of theoretical stages. We're going a bit slow, but I think I will finish it in the next 5 to 10 minutes, and then we will go to Aspen HYSYS. Number of theoretical stages and where your feed enters. So we will try to, so you don't have to break your head. Yeah, so Aspen have some shortcut method. We call it as a shortcut distillation method. If you go into some nice chemical engineering textbook, like I can recommend some book for distillation, so you can check these books to in order to know how the shortcut distillation method works. But for the moment we can do that in Aspen HYSYS. So using the shortcut distillation method, we will find, we will we will get some information about what will be the temperature that we need to fix in the condenser, what should be the temperature in our reboiler, number of theoretical stages, and where our feed enters. So these things we will calculate using Aspen HYSYS. So once we get these values, and then we will build something, we call it as a rigorous distillation column. We will enter that particular condenser temperature, we will add that particular reboiler temperature, we will give the number of stages that we calculated using the shortcut distillation method, and then we will see how pure our final product is. Yeah, I think this is more than enough for the moment. I think I don't have to summarize anything for the moment. For when you are going to use Aspen HYSYS, you are going to set all the process conditions and the stream flow rate, whatever we fixed in this lecture 2. I said the flow rate of what? The flow rate of ethylene will be somewhere around, let me check one time, my notes will be around 350 kilomoles per hour, and then we will supply chlorine in slightly excess to that of the stoichiometric amount required to completely convert your ethylene into product, which is ethylene dichloride. And then we will do the same for the oxychlorination process. We will supply slightly excess of HCl, and then we will mix those two product streams, the one which comes out from the oxychlorination and then the product which we get from the direct chlorination reaction. We will mix them, and then we will purify the final product, so that we will, the whole objective is to achieve a purity near to 99.5 percentage, and then we will pass that particular stream. We will pyrolyze that pure ethylene dichloride in order to produce vinyl chloride monomer, and obviously we also need to get nearly 99.5 percentage pure vinyl chloride monomer. So we will add a distillation column in order to achieve that particular separation. And obviously you should know how to design the distillation column. Yeah, so for that we will rely on Aspen HYSYS. So I will make a separate video just on the distillation column. Yeah, so because it will go for around roughly 30 minutes. So we will, so you will learn how to use the shortcut distillation method in order to get some parameters, and you use those parameters. Based on that, we will build a rigorous distillation column. So these are the information that you need. So once you finish listening to this lecture, take a notebook and just list all the process conditions in a piece of paper, and then go to the lecture 3. So just list like what are the unit operations we have. So CSTR, PFR, something like a catalytic reactor, and then we have a pyrolysis chamber, and then in terms of reactants we have just write it, ethylene, hydrochloric acid, Cl2, and then we also need air, so instead of air we can supply oxygen, or we can use directly air instead of oxygen. Yeah, so these are the feed streams, and then the product stream will be ethylene dichloride and then vinyl chloride monomer. Obviously these two, ethylene dichloride is our intermediate product, and then vinyl chloride monomer is our final product. And then take a list of the, or just write down the stoichiometric equation for the three reactions like direct chlorination, oxychlorination, and then pyrolysis. And then take a note of the, the enthalpy of the reaction, and then write down the rate expression for all the three reactions. So what's the rate expression, what's the rate expression, what's the rate expression, and then kinetic constants involved in those rate expressions. Pay attention to the unit, what's expressed in joules, what's expressed in kilomoles, what's expressed in seconds, and so on. And then process conditions. Take a note of process conditions like so what's the temperature for oxychlorination, temperature for the direct chlorination, oxychlorination, pyrolysis, and same what's the pressure for oxychlorination, what's the pressure for direct chlorination, and what's the pressure we need to maintain in the pyrolysis chamber. And then obviously we are purifying everything that we are going to see. So in this case we are going to use, let's add up to this unit operation. So we are going to use a flash column, and then we are going to use a liquid extractor. Liquid extractor, what else? I forgot honestly. Liquid extractor, and then a reboiled absorber. So in fact we are learning almost everything in the Aspen HYSYS through this one example. And then distillation column. Then we are going to learn some technique, something how to use a shortcut distillation method to get some parameters. We will get some parameters which we will use to design a rigorous distillation column. And then we will also give some justification like why we are using distillation column in order to separate vinyl chloride monomer from ethylene dichloride and HCl if there is any in the product stream. Yeah, so that's the entire project. And take a note, and also take a note what's the temperature and pressure in flash column, what's the temperature in liquid extractor, what's the temperature and the pressure that we need to maintain in the reboiled absorber. Regarding distillation column, I already said what should be the process conditions, so where we can perform this particular unit operation in a more economical way, yeah? Like so that we should we should maintain the reboiler temperature less than I think 186 degrees centigrade. Since you are a chemical engineer, it's also not a bad idea to remember these values, and then we should also maintain the condenser temperature to 25 to 49 degrees centigrade. Obviously, if this is not like a universal rule, if we cannot achieve the separation in this particular range, obviously we have to think about other things. Yeah, we can even use some other refrigerant in order to maintain some low temperature in the condenser. Yeah, so keep those things in the mind. For example, imagine if you have a fluid. In fact, your vinyl chloride monomer itself will condense at negative temp somewhere around minus 27 degrees centigrade. Yeah? So in that case, I'm not sure, we will check that when you are going to design the distillation column. So in that case we cannot use like water from the river. We have to think about using some other refrigerant. So we will learn all those things in the final part of this lecture. Yeah, so when you are going to deal with the distillation column. So I will stop now, but it is your job to listen to this lecture line by line and take the full list, like different unit operation, temperature, pressure in those unit operation, what are the product stream, and we already said the flow rate, like ethylene 350 kilomoles per hour. So you know the stoichiometry. So from that you can calculate what should be the flow rate for hydrochloric acid, what should be the flow rate for chlorine, what should be the flow rate for oxygen, and so on. Yeah. And I think that should be enough. And whatever the information that you are going to write in the pen and paper, that's the information that you need when you are going to do your final year design project. Yeah? And also for the project that you need to submit as assignment for this particular module, CG5031. So keep these things, and all these things will look bit tough, but once you manage to develop your full process flow sheet, even for this vinyl chloride monomer, it will give you huge amount of confidence to work with Aspen HYSYS. So you know how to manufacture this particular product, and you know how to get the information from the literature already, and we know what are the information that we need, like we also we talked about all the essential things, like the stoichiometry, the rate kinetics, the process conditions, and the different type of unit operations where we perform the main reaction, and then where we perform the purification processes. So everything we have it in the hand. So now it's time to go to open the software, and then we are going to draw the flow chart line by line. And one thing we should remember, like every stream that goes in, that should comes out, should have some particular temperature and pressure. So these are the key things that you should remember in the mind. So I'm going to call this as let's change the color. So I'm going to call this as key sheet. So when you're going to lecture 3, when you're going to listen to lecture 3, you should keep your key sheet in your hand, obviously with more details. Yeah, so you should know what's the temperature, pressure, the rate expression, pay attention to the units and everything. Yeah? So, and if you have any doubts, you can obviously email me, or you can even call me through MS Teams. So thanks for listening.